Hello students, today we are going to discuss about the topic dynamic memory allocation. Dynamic memory allocation. So before dynamic memory allocation, we must know what is static memory allocation. Memory allocated during compile time is called static memory allocation. Now what it means during compile time, that is called a static memory allocation. For example, we have written a program like this. So for example, this is a program. We have a main function and we have declared an array of size 9. So we can store 9 elements in this array. So static memory allocation means that the size is fixed during compile time only. In this, when we are declaring this, the size is fixed. That it can store, this array can store 9 elements in it. Now, it is called static memory allocation when the size of the memory is fixed during declaration time. That is why it's called memory allocated during compile time is called static memory allocation. Now what are the problems that are faced in static memory allocation? If we are allocating memory for an array during compile time, then we have to fix the size at the time of declaration. And we have fixed here. We have fixed the size that it can store 9 elements in an array. Now, there are two situations. Take first situation when we want to store only 5 elements in an array. First situation is we want to store only 5 elements in an array. So, the memory is wasted. Okay, the memory is wasted. There is a wastage of memory because we can store 9 elements, but we are storing 5 elements. First problem. Now take the another situation. We want more 3 elements to be added in this array. We want more 3 elements to be added in array, but the size is fixed at the compile time. So to add more 3 elements, we have fixed size as 9. Whenever we want to store more 3 elements in an array, the program may crash, or there will be a crash in memory. Okay, so these are the two situations or two problems we face in static memory allocation. Now, because of these disadvantages in static memory allocation, now comes the dynamic memory allocation. But one thing I want to make it clear, that it's nothing like the size is allocated, the memory is allocated during compile time. Because I have already told you, compiler only changes the high level language, the program we are writing in English level language, English like language, to object code, then to executable file, and then link with linker and loader, then it converts. And when the program is in main memory, then only we will allocate the memory from the RAM. So main thing in static memory allocation is this, that the memory allocated is fixed. This fixed word is this. Okay, because the memory allocated is fixed. As here, it is fixed during declaration. If I am writing some more, like I am declaring in A, B. Okay, I am declaring here A, B. That means the memory is fixed. For A, it is 4 byte as it is integer. The memory for B, 4 byte because it is an integer. So main thing in compile time or static memory allocation is that the memory is fixed. Okay, at this declaration phase. And the problem I have already told you what are the problems we face in static memory allocation. Now comes the dynamic memory allocation. In dynamic memory allocation, the memory is allocated at runtime. So we have to note 2 points here in dynamic memory allocation. First pointer plays an important role in dynamic memory allocation. And second is allocated memory can only be accessed with the help of pointers. Allocated memory will also be accessed through pointers. So pointers plays an important role in dynamic memory allocation. And you can just take an example of this dynamic and static memory allocation. Like we have a full glass of water and we have to use it. That is, we have full glass of water, we have to use that water only. That is static memory allocation. And we have a jug with water and we have an empty glass. So whenever we require water, we can put it in the glass. Whenever we require, we can add, we can do anything. So that is your dynamic memory.